Hi, this is Mrs. LaBarbara. This is Physics Chapter 3 Vectors, Video 6. Today's topic is adding vectors using components. The objectives for today is to be able to combine the principles of vector resolution with the Pythagorean theorem to determine the resultant of any vectors. First, let's look at a case of right angle vectors. How do we add more than two right angle vectors? We have red, blue, and green. So from graphically, we can draw it out. We can draw red, then we draw blue, then we draw green, then the resultant is from the beginning of the first to the end of the last. So we can measure out very carefully, we can determine the resultant, then we can use protractor to measure the angle. But we can also determine the resultant mathematically. How can we do that? We simply reconstruct your diagram. Move the green to the left, line up with the red. Then move the blue up. Now you have a right triangle. We know how to deal with right triangles. So from here we can find the hypotenuse. So the hypotenuse squared equals 6 squared plus 8 squared. 8 is 6 plus 2. Then we can find angle, use inverse tan. So you have a procedure here. First, you add all the horizontal components. All the horizontal ones add together. Then you add all the vertical together. Then we use Pythagorean theorem. Then we use the inverse tan to find the direction. So in this case, r equals to 10 kilometers. 10 equals to square root of 6 squared plus 8 squared. And 37 degrees, theta 37 equals the inverse tan of 6 divided by 8, because that is the angle by the tail of the resultant. Now let's take a look at this example. So this has 4 vectors. So again, we add all the horizontals together and all the verticals together. Horizontal, you have 36 west plus 16 west. They're in the same direction, so basically you just add them together. But for vertical, you'll have a south of 22 meters, and you have north of 24 meters. So you'll have a net of 22 meters in the north. So the horizontal components, you'll have 52 meters west, but vertical components, you'll have 22 meters north. That will be -2 plus 24. That's how you have 22 meters north. Then we add these two together using Pythagorean theorem, you'll have 56 meters. Finally, we use the inverse tan function to find the angle. You'll have 68 degrees. Remember, the angle is, again, it's the end, the tail of the resultant vector right over here. Now let's do another example. Use the Pythagorean theorem and the SOHCAHTOA to determine the magnitude and the direction. This using compass point of each resultant. So here's the compass point. So resultant is just from the beginning to the end. That's a resultant. So to find a resultant, we add all the horizontals together, 7 plus 5, which is 12, and all the vertical together. The vertical is just 5, and here is the resultant. To find a resultant, we use 12 squared plus 5 squared, which give us 13. To find the angle, we use inverse tan of 5 over 12. So you have 23 degrees, it's north of east, because you measured from east, you're going to the north. Take a look at this, which is the same thing, 7 plus 5, all the horizontals together, and the vertical in this case is downward at 5 meters, because it's -12 plus 7, so you have like -5. Here is the resultant. Same thing, 5 squared plus 12 squared, so you have 13, and here is your angle. So your angle is the same angle, 23 degrees, except you are going to the south from the east. So it's 23 south of east. We can add any vectors with any angle that's not perpendicular using component method. Let's see, here is D1, here's D2. They are not perpendicular to each other. How do we add these two vectors? So we can use tip and tail to add vectors, draw a line. So here is your R. How do we find that R? Well, this is what we can do. We can draw, see this right triangle. If we can find the side of the legs of this right triangle, then we can find the resultant. And we can also find the direction of the resultant using inverse tan. How do we find the size of the leg? Well, D1 has two components, delta x1 and the delta y1, right over here. Delta y1, we just moved over here. D2 also have two components, delta x2, right over here, and the delta y2. And so the size of the whole right triangle is simply the x1, delta x1 plus delta x2. And the y part is delta y1 plus delta y2. So let's see. First step, you have to find x and y components for each vector. D1 has delta x1, delta y1, and D2 has delta x2, delta y2. Then we add all the x components together. So Rx equals delta x1 plus delta x2. That is this. And we can find y components of the resultant, which is delta y1 plus delta y2. Now we can use Pythagorean theorem to find the length of the resultant. Then we can use inverse tan to find the direction of the resultant. Let's take a look at an example. Use the following vector diagram. I'll consider the following vector diagrams for the displacement of a hiker. For any angled vector, use SOHCAHTOA to determine the components. Then sketch the resultant and determine the magnitude and direction of the resultant. So in the first example, 12 meters is the one at an angle. So first we have to find x and y components. Because the angle is with x, so we can use the equations in the reference table. The x component equals to 12 times cosine 30, which gives you 10.4. The y component is 12 times sine 30, which gives you 6. Then we draw the resultant. So from the resultant here, let's see what is the x component equals to. You add all the x together. 5 plus 10.4 plus 4. That gives you 19.4. Oh, the y component is just 6 because only 12 meters has y component. You'll have the x and the y. Now you can use Pythagorean theorem to find the length of the resultant. After that, you can find angle. The angle is the tail of the resultant, so you use inverse tan of the opposite over adjacent. In this case, opposite is 6 and adjacent is 19.4. You'll have 17 degrees. Take a look at the next example. 14 meters is the one has x is the vector has an angle. So we need to find x and y component. Each one will give us 9.9 meters. This is because over here is 45 degrees. When it's 45 degrees, x component equals to y component. It's isosceles triangle. Next one, the resultant is from the beginning to the end. And here is the x component and here's the y component. To find x component, we have to add 9 plus 9.9. You have 18.9. To find a y component, you have positive 5 because that's going up, plus negative 9.9. It's negative because it's going down. So we have negative 4.9. This negative just means it goes downward. Then we find the length using Pythagorean theorem. You have 19.5 meters. Then we find the direction. Direction will give us negative 15 degrees. It's negative because it's going downward. It's clockwise. This one is counterclockwise, is positive. Clockwise is negative. So below x-axis, you have 15 degrees. That's it for today. Thanks for watching. See you next time.